Okay, so as mentioned earlier, we will start with our next module. The name of the module is multiple integrals. So in this module, we'll be learning double and triple integrals. So first of all, we will understand double integrals because triple integral goes on the same lines. So instead of talking a lot of theory, I'll directly write an example. And once we solve a single example, which will clear a lot of concepts, as I hope. And then we will talk about the theory behind the double integral. So evaluate integration 0 to 1, 0 to 1 minus x plus y dy dx. So double integration actually means you have two integrations, but these two integrations are with respect to different variables x and y. Okay, so in order to solve it, what I will do is I'll classify this. What do I mean by classify? You solve one integration first, 0 to 1 minus x plus y. Then you have dy bracket complete d. What is this bracketed term integration is with respect to? Bracketed term integration is with respect to y. These limits are going to be for y. Okay, so when I'm integrating with respect to y, so integration of x, what will be the integration? Yes, anyone?
X
So
into
what
Y.
your x into y plus
Y square upon 2.
y square upon 2. Because what we are doing here is we are integrating with respect to y. So x will become constant. So first observation, integration with respect to x. With respect to x, treat y as constant and vice versa. In vice versa, I will mean that when I'm integrating with respect to y, you treat x as constant. So this is the first observation, very important observation from the perspective of solving a given example or integration. So 0 to 1 minus x dx. Let's put the limits. What do we get? These values are for y. Remember that your integration is with respect to y. So these values are for y. So x into 1 minus x plus 1 minus x whole square divided by 2 bracket complete dx. So this is equal to integration 0 to 1. You'll have x minus x square plus 1 by 2 minus x plus x square divided by, please check the calculations. There is a shortcut way of doing it is directly you integrate this 1 minus x whole square, but I have squared it. No problem. So x plus x minus x what we have is minus x square plus x square by 2. 1 by 2 minus x square divided by 2 dx. The integration is, I'll take out 1 by 2, integration is x minus x cube divided by 3, limits from 0 to 1. And I put the upper limit, what do we have? 1 by 2 in bracket 1 minus 1 by 3. So the answer is going to be 1 by 3. So there are 2 to 3 types of examples in double integral. Okay. The first thing is you directly solve the given integration. Solving, as you can see, without even knowing the background or the theory behind the double integral, we can solve it. So if the limits are given, solving a integration, double integration is very easy. You simply remember the rule that if you are integrating with respect to x, you treat y as constant. If you're integrating with respect to y, you treat x as constant. Okay. So now I will try to go behind, I mean, try to talk about the theory behind this double integral. That again we will do with the same example. I hope till this it is clear. So I'll repeat the same integration on the next page. Limit 0 to 1, 0 to 1 minus x. Integrand is x plus y. Then we have dy dx. Yes. So what we will do is we'll talk about the limits now. These limits are for, the outer limits are for anyone? 0 to 1 is the limit for which variable?
X,
X, X,
X value.
X. X. And the inner limits are for y. And how do you decide this? Yes, anyone? How do you decide that?
Position of dy or dx.
So position of dy and dx. So that is a very good observation that this order is going to define the limit. Okay. And another observation is कि integration जब तुम solve करोगे, you should always get a constant number. Uh, Constant number is something that you should get whenever you solve an integration. After solving, you can never get a variable. Okay, but if you have, say, if the this same example is written like this: 0 to 1 minus x and 0 to 1 x plus y dx dy. So if you solve this, what you are going to get? 0 to 1. If you solve the inside integration, so this is very much absurd actually. X square by 2 plus xy 0 to 1 dy 0 to 1 minus x. Look how problematic this case becomes. So these values are for x. So we'll put the values of x. So 1 by 2 plus y dy. So if we integrate this, this will be y by 2 plus y square by 2, 0 to 1 minus x. So if you solve this, our answer is going to be in terms of x. So definite integral never gives you an answer in terms of a variable. Okay. So whenever we are solving an integral, we should always get answer as a constant number, definite integral. Okay. So this is actually wrong. So whenever we are giving limits for an integration, the outer limit needs to be constant. जैसे कि in this case x is fixed, so x is taking constant. So this x I can use in the next integral. Okay, so you can see that 0 to 1 minus x. So I'll write down the limits now. X is running from 0 to x equal to 1. What about y? Y is running from 0 to y equal to 1 minus x. You can simplify this equation and you can see that this is x plus y equal to 1. Let's draw the diagram. And then we will draw the, what is the equation? X plus y equal to 1. What is this? This is a straight line. If I want to draw this line, there is a simple 10th standard technique that you use. You have x, you have y. So you put x equal to 0, you will get y equal to 1. You put y equal to 0, you will get x equal to 1. So you plot the points 1, 0, 0, 1. This is the line. Okay, so this is the line x plus y equal to 1. Now think of the limits. What are the values of x? X are going from 0 to x equal to 1. X कहाँ से कहाँ तक जा रहा है? From this point 0 to this point 1, right? So x is going from 0 to 0 to 1 0. What about y? Y talks about, what information does y give you? The y-axis represents the vertical length, right, of your region. Okay, so the value of y goes from 0. Y equal to 0 is this line to y equal to 1 minus x to this line. Okay, so this is the region over which you are integrating. You can see that both the conditions are satisfied in this region. What is your x? X is running from 0 to x equal to 1. What is the value of y? Y goes from y equal to 0 to this line, y equal to 1 minus x. If anyone have any difficulty in this, please ask right now. Because this technique will be used almost in every example. So double integration, what you do is you integrate it over a region. Like in your 12th standard, you have seen that integration f of x dx from a to b. So single integration was done over an interval. Now you can see that double integration, you integrate over a region. Double over integration over a region in two-dimensional space. So triple integral will be over a volume. Fine. Kunal, is it clear?
Yes, sir.
Anyone having a problem after this? Fine. So look, there is an idea when you are covering a particular region. So I want to cover this whole region with a small rubber, I should say. Okay. If I want to cover this region, whenever I want to give the limits, the idea is you take a horizontal strip or you take a vertical strip. Okay. So whenever I want to cover this region by this straight line, so how you are going to move this line, vertical strip, how you are going to move on x-axis, the movement will be like this, and the length of this strip will depend on its distance from the x-axis to this line. Okay, So whenever you draw a vertical strip, your x becomes constant. So you can give the value of x. You will move this strip horizontally from the point x equal to 0 to x equal to 1. And how much length you are going to give to this strip? The length will be from the line x equal to 0, sorry, y equal to 0 to this line. On this line, the value of y is 1 minus x. So this is how you actually give the limits. The similar thing can be done horizontally. Now, this is where I will need some conversation from your side, and that will help even you to understand how you are giving the limits. Now, I will draw the horizontal strip like this. So, can someone tell me how you will define the movements of the strip in order to cover your region R?
So vertical.
So, you will move it vertical from where to where?
From line x
0 to
equal to
1.
0 to
Which
0 to 0.
there are two
0
variables here. Y
y.
joining from
Y is
0.
equal to 0 to y is equal to 1.
0 to
What about x? What about x?
M star 0 to
Same 0 to 1?
sir.
Yes.
When we move through y, x is getting covered.
0 to 1 on sir 0 to the point on the line. Y is
0
equal
to
to
the
1.
point on the line. The point on the line is not constant, right? So
Yes, sir.
it will depend on something else. जैसे कि अगर तुम ये point पे देखोगे, the value of x is going to be something different. At this point, the value of x is going to be something different. At this point, the value of x is going to be something different. So what will be that value of x?
1 minus y.
0
1 minus y.
to
0 to 1
x
minus
equal
y.
to 1.
Equal to 1 minus y.
Exactly. So in this integration, the strip was parallel to which axis? Earlier, the strip was parallel
y.
to y axis. Now what we have done is we have changed the orientation of the strip. Now the strip is parallel to x axis. So these are going to be the limits when the strip is parallel to x axis. Okay, so this is how this complete double integration works. With just one example, I have actually tried to explain you everything about the double integral. There is nothing in this whole chapter beside this. So if you have understood how do you take a strip, how do you give the limits, and you do all these things, then you'll be able to solve almost all the examples. But surely we'll go to the theory part again now. So this is
Sir,
where
I
the
have doubt, sir.
yes, yes,
Sir, in between the lecture, you gave a statement that single integration is done over a period, over a interval, and double
yes,
integration is done over a region, right?
yes.
So, can you explain it once more again? Like, I didn't get you.
ये लिखा है यहाँ पे देखो. So when you are having integration a to b f of x dx, so this integration a to b, what is this? If you look at the real line, a is somewhere here, b is somewhere here. So you are integrating f of x over this interval a to b, है ना? Yes or no?
Yes, sir.
Yes, yes.
But
And now in this example, if you combine these two limits x and y, combining these two limits, what do we see here is in the diagram, this is my region over which I am integrating. So this is a region in R2. This is not an interval, right?
yes, sir. Yes, sir.
Yes,
Got it. It is done over two variables, right?
yes.
Thank you.
So now we will go ahead. So draw the diagram. We have the integration y is equal to something. So we have a, b. This is y is equal to f2 of x. Y is equal to f1 of x. This is my region of integration. Mark first one. So this is the case one. I will be given by, yes. Anyone? How do you take the limits? It will be better one. X will be running from
A to B.
A to B. Y will be going from
F1 to F1x to F2x.
F1 of x to F2 of x, whatever the integrand is, x comma y. What will be the order?
dy dx.
dy then dx.
Dy dx. What is the strip that you have considered here? The strip is vertical. If I'm not wrong, you have fixed x. So for vertical strip, which variable is constant? Always which variable is going to be constant if the strip is parallel to y-axis?
X.
X is going to be constant. So if strip parallel to y-axis, x has to be constant. Second, I'll draw another diagram now. This is C, this is D, this is x equal to g1 of y, x equal to g2 of y. This is the region R. So what do we have? Integration. Now which strip is to be considered? You can see that the values of y are constant. So make the strip parallel to x-axis here and give the limits. So y is running from?
C to D.
Why not D to C?
Is lower limit to upper limit.
Yes. So smaller has to be the lower limit. What about x?
The G1Y to G2Y.
G1y to G2y. Can I take G2y to G1y?
No, sir, like the smaller limit to higher limit, right?
Yes, the value of x is smaller on G1 of y. Okay. So if you observe even in your 12th standard, your limits actually go from the smaller point to the larger point. So in the same manner, we should be thinking. So this is the convention that we follow. So we have a lower limit on the left hand side for x-axis, and right hand side limit is going to be the larger one. Order is dx dy. So write down if the strip parallel to x-axis, then y becomes constant. So the remark number 3 will actually make your life very much easier. The third remark says that if
Sir,
Sir,
previous
can you
slide.
go to the previous slide?
done,
Yes, sir.
so now I will this is the region R over which we need to integrate. This is A, this is B, this is C, this is D. What can you say about the integration? What will be the limits
Sir,
in
it
this?
doesn't matter. It doesn't matter here because whatever you
What?
take, you'll get the constant as the answer.
Yes, exactly. So X is running from A to B, Y is running from C to D, f of xy, dy, dx. So this will also be same with y equal to c to t, x is running from a to b, f of x comma y, dx, dy. So if the limits are constant, the order doesn't matter actually. Even when limits are not constant, order doesn't matter. Final answer is going to be the same. But what's the difference here is the integrand doesn't change, and even the limits remain the same when those are constant. So for a rectangle, only those both the limits are constant. So if you don't have a rectangle in your diagram, you should not get both the limits as constant. Fourth and the most important. So if R is defined by, if R is defined as x equal to A to x equal to B, y equal to C to y equal to D, and f of xy, x comma y is equal to u of x, v of y. Then I is equal to integration x is equal to A to B, y is equal to C to D, f of x comma y, dy, dx. This is equal to look, f of xy, this is saying that you can write this function f of xy as product of the function of x and function of y. So if this kind of case occurs, where both the limits are constant and your function can be separated as a function of x and function of y, then this integration can easily solved by this x equal to a to b u of x dx into integration t to d v of y dy. Uh, Memorize this right now because MCQ type questions can be based on this. Like limits can be given and evaluate the integration. So at first it will look very much difficult, but you can see that it can be solved really easily if the integrand is. I mean, if you're able to write down the integrand as product of function of x and function of y. So things become very much easy in this case. So I will recall this from time to time because in triple integration, more than double, we use this in triple integration. There we can separate and directly write down the answer. Fine. After this, some basic properties. Whatever properties you have seen in your 12th standard, the same property works for double integration as well. So double integration over a region R, k times f of x comma y dx dy. This is equal to, yes, k is a constant. What can I do?
So you can take k out of the integration.
Exactly. So k can be taken outside the integration. So just like single integral, even in double integral, constants can be taken outside. Second, double integral over R, f of x comma y plus minus g of x comma y dx dy. So this is equal to, yes,
So we can write them separately.
yes, you can separate. So whenever there is a addition subtraction, just like our previous integrations, we can even separate the double integral. So double integral over R, f of x comma y dx dy plus minus double integral over R, g of x comma y dx dy. Third, if R is equal to R1 union R2 and R1 intersection R2 is equal to 5, then double integral over R f of x comma y dx dy. This will be equal to, I'll just give you a rough idea. So you have a region R over which you are integrating, but in R, R is actually the union of two sets, R1 and R2. So you can see that R1 union R2 is complete R and R1 intersection R2 is 5. So what can we do here? You just have to relate this to some property that you have
So we
studied.
can separate.
You can separate,
First integrate with
from 0 to R1 to R2.
this you will.
so over R1 f of x comma y dx dy plus double integral over R2 f of x comma y dx dy. So this is just the generalization of property. So you have seen this in your 12th standard, and that is a to b f of x dx. And if you have any point C between a and b, then what you do is a to c f of x dx plus c to d f of x dx. So this property that I have written right now is just the generalization of the previous property of definite integral. So again, in change the order type of examples, you'll need this property. So if you have written it, I can go ahead now.
So then what was the use of phi there?
Where?
Sir, in property 2.
This phi means the empty set.
Okay, okay.
Phi means the empty set. If their intersection is empty, look, अगर intersection अगर empty नहीं आता है, so this integration will be, I mean, counted twice, even in the previous and the new one. So intersection has to be empty if you want that answer to be exact. Fine. So I hope all the things are clear. So I can start with some nice examples. Evaluate. Integration 0 to 1. Second integration 0 to 1. Dx dy upon 1 plus x square 1 plus y square. Anyone?
So both limits are constant, sir. So
Yes.
then we have to integrate first by dx. So tan
Hmm.
inverse x we get, and after that we integrate tan inverse y.
Okay. Anything else? Anyone have any other way of solving it?
But if we can reduce it to like convert it to addition, so we can separate the integrals again.
Okay. Anyways, so 1 upon 1 plus x square 1 plus y square. This is your integrand. So this can be written as 1 upon 1 plus x square into 1 upon 1 plus y square. So integrand can be separated as u of x and u of y, as well as v of y, as well as our limits are constant. So by the fourth property, as I said, will be used a lot of times. So 0 to 1 dx upon 1 plus x square, second bracket integration 0 to 1 dy by 1 plus y square. Now you integrate. So this will be tan inverse of x 0 to 1, tan inverse of y 0 to 1. So the answer is pi square by 16. Yes, Ravi, was it the same thing you are speaking about? Ravi or Yuvraj, I don't remember. Okay. Next example, I'll need the answer from your side now for this. Evaluate integration 0 to 1, integration x square to 2 minus x, y, dy, dx. Yes, please solve it. So what is the answer? Anyone? First integration will be y square by 2 limit from
The
x.
final answer will be 1.
No.
Sir, 16 by 15.
Yes, exactly. So this is integration 0 to 1 2 minus x square by 2 minus x raised to 4 divided by 2 t, which can again be 2 minus x cube divided by minus 6 minus x raised to 5 divided by 10, limits from 0 to 1. So I hope that this is 16 by 15. Yeah, I won't go into the details. Fine. So this is the first type of example where the limits are actually provided to you, and what you actually need to do is just solve the integration. The next type of examples are where limits are not at all provided, but we need to solve the integration by the given information. So example is double integral over r y dx dy, where r is y equal to x square, comma x plus y is equal to 2, comma x equal to 0 in first quadrant. So as we saw earlier examples, we had this limits given to us. But now the equations are given, we need to actually draw the diagram first, and then we need to give the limits. Later that will be solvable. So first equation y equal to x square. First of all, draw the graph. That is the key to each and every example. So y equal to x square, what is it?
Upward parabola, sir.
Parabola which is opening towards positive y. The other equation x plus y equal to 2. So y equal to x square parabola. X plus y equal to 2 is a straight line which has 2 comma 0 and 0 comma 2 as the 2 points. The line x plus y equal to 2. So what they're saying, the region is bounded by this parabola, this line, and x equal to 0. X equal to 0 is the y-axis. Which is the region? A region is this one. Please check it. So this is the region over which I need to integrate. Now my next question is whether I should take horizontal strip or vertical strip.
Horizontal strip.
Why not vertical?
So
So this is the another aspect to which I want to draw your attention is, look, if I take horizontal strip, I will draw two strips over here. The first one S1 I will call it. I'll call it S2. Yes, I want you to tell me what is the difference between these two strips.
Sir, one strip's value of x depends
for-
on y is equal to x square.
and the other for y.
Yes, exactly. So the major difference is if you look at the strip S1, the right hand side limit is on the parabola, whereas for S2, the right hand side limit is on the line but and not on the parabola. So what I will have to do is I will have to divide this. Where does this change the limit? The limit changes at this position if you see. At this position after this point, if you are making a horizontal strip, so when you make a horizontal strip, what you will do is you will move it vertically. And while moving it vertically, once it passes this point, I'll name it capital A. After that, the limits change. So what I will have to do is the below one I will have to call R1, above one R2, and this integration will be divided into two parts, integration over R1, integration over R2. But what if I take a vertical strip? Does the limit change? What if I take the vertical strip?
For vertical strip, maybe it is the same because it's for y.
Yes. So if I take the vertical strip like this, you can see that throughout your region, the limit, the lower limit as well as the upper limit remains the same. The lower is always on the parabola, the upper one is always on the straight line, right? So it is convenient for me to take the which strip? Vertical strip. So
Vertical strip.
look, this is what you have to think while you are solving an example. Remember that. So consider strip parallel to y axis. So when you consider the strip parallel to y axis, which variable is going to be constant? X or y?
X.
X. So x is running from 0 to look, let's find this point of intersection. How do you find the point of intersection? To find A. And
So we put y is equal to x square in the equation x plus y is equal to 2.
so put y equal to x square in x plus y equal to 2. So that will be x square plus x minus 2 equal to 0, which means that x is equal to 0, comma,
X is equal to 1 or comma minus 2.
So the
0
point
and
of intersection is 1 comma 1.
1 comma 1. There
1
is
comma
something on the left hand side too, right? x की एक negative value भी आनी चाहिए.
yes sir, minus 2 and
So
1.
it's
Minus
1
2.
and minus 2.
Yes, exactly. So x is equal to 1, comma, minus. So this point is x coordinate is 1 and y coordinate will also be 1. So x is running from 0 to x equal to 1. So farthermost point on x, that is what you need to see. So y. So for y, what we look at the lower limit of your strip. So lower limit of your strip is this parabola, right? So on parabola, the value of y is x square 2. Upper limit of your strip is on this line. On this line, the value of y is 2 minus x. I hope this is clear. So I is equal to 0 to 1 x square to 2 minus x to y. What I should write first? Dy or dx? Dy dx. What is the answer for this? What's the answer for
16
this?
by 15.
Just now we have thought. Clear? So I hope I have made a lot of things very much clear. So for today we will stop here.
Sir, please explain the second line, sir. Y equal to x squared to y equal to 2 minus x.
Look, we have considered here a strip. So all my calculations depend on this strip. So horizontally, this strip is going to move from this point x equal to 0 to this point x equal to 1. Right? So horizontally, I will move this strip. And now, y क्या idea देता है मुझे कि length कितनी है strip की? So you look at the lower end of your strip. Lower end is on the parabola. So parabola के ऊपर y की value क्या है? X square. What is the upper end of the strip? Upper end is on this line. और ये line के ऊपर y की value क्या है? 2 minus x. And that's why y is equal to x square to y equal to 2 minus. Is it clear?
Okay, sir. मतलब वर्टिकल स्ट्रिप ये लेंथ की मतलब वो देते हैं
हाँ,
इंफॉर्मेशन.
yes. So you look at the length for vertical. Lower end, upper end, left hand side and right hand side end. So अगर vertical strip है तो y की value देते time you look at the lower end of your strip, you look at upper end. If you have the strip horizontal, then you will look at the left hand side end of the strip to the right hand side end of the strip.
Okay, sir.
So the link for the attendance is given to you in the chat box. You can mark your attendance.